Hi everyone. Today we're going to study total differential. Let f of xy be continuous on an open set S. Let dx and dy represent changes in x and y respectively. Then the total differential of f is df. This is the total differential equals partial derivative of f with respect to x multiplied by dx plus partial derivative of f with respect to y times dy. Sometimes this is also called total derivative. Example 1. Find the total differential of f of xy equals 100 plus 5x squared plus 6y raised to 5. Let's begin with simplification of partial derivative of f with respect to x. We can copy this on the side and let us evaluate. So the value will be 10x because derivative of 100 is 0 because this is constant. Derivative of 5x squared is this 10x. Derivative of 6y raised to 5 is 0 because y variable is taken as constant. Let us now simplify the partial derivative of f with respect to y. So the value will be 30y raised to 4. Derivative of 100 is 0 because this is a constant. Derivative of 5x squared is again 0 because x here is taken as a constant. Derivative of 6y raised to 5 now comes the 30y raised to 4. Next, let us do the substitution respectively. So the df or the total differential equals 10x dx plus 30y raised to 4 dy. This is the final answer. Example 2. If f of xy equals x squared y squared minus 2x minus 4y, then find the total derivative of f at x equals 1 and y equals 3. First, let us evaluate the total differential, and here is the formula. Let's begin now with evaluating the partial derivative of f with respect to x. So that will be 2xy squared minus 2. Then partial derivative of f with respect to y. And the value will be 2x squared y minus 4. Then let us do the substitution respectively. So we have like this. Next step, we're going to substitute x equals 1 and y equals 3 respectively in this equation. So we will have like this. The 2xy squared becomes 2 times 1 times 3 squared. Then we write the minus 2 here. The 2x squared y becomes 2 times 1 squared times 3. Then minus 4. Then we copy the dy. Simplifying further, this 3 squared is 9. 9 times 2 is 18. 18 minus 2 is 16. So we have 16 dx plus 2 times 1 square is 2 times 3 will be 6. 6 minus 4 is 2. So we write here 2 dy. This is the final answer. Example 3. If f of xy equals x squared y squared minus 2x minus 4y, then find the total derivative of f at x equals 1, y equals 2, dx equals 0.2, and dy equals 0.4. Let us write the formula for total derivative or total differential. Please remember that this function is the same from example 2. We are able to get the value of the differential. We'll just copy it down here. The next step is we're going to substitute the values. X equals 1, y equals 2, dx equals 0.2, and dy equals 0.4. And it will be like this. 2xy squared becomes 2 times 1 times 2 squared. Then we copy the minus 2. Multiplied by dx, and we replace this by 0.2 plus 2x squared y becomes 2 times 1 squared times 2. Then we copy the negative 4. Multiplied by dy, we replace dy by 0.4. Simplifying further, this 2 square will be 4. 4 times 1, then times 2 is 8. 8 minus 2 will be 6, multiplied by 0.2, plus 2 times 1 square is 2. 2 times 2 is 4, and 4 minus 4 will be 0, to be multiplied by 0.4. And we can cancel this product because of the 0. So the df equals 6 times 0.2. And we have the final answer as 1.2. I hope you learned something from this video. See you again next time.